All right, welcome back. After getting a handle on lists and tuples, we're going to dive into two more of Python's most powerful data structures, sets and dictionaries. And trust me, these aren't just for storing stuff. They are absolute secret weapons, optimized for incredibly fast lookups and for guaranteeing uniqueness, like instantly. So let's see how they work. So let's start with a couple of problems you probably run into. First, imagine you've got this huge list of user IDs, right? But it's messy, full of duplicates. How do you get a clean, unique list out of that fast? And second, how do you store a user's profile, their name, age, location, so you can grab any piece of info you want just by its label without having to guess its position? Well, Python has some brilliant built-in tools for exactly these situations. For that first challenge, making sure every single item is unique, Python gives us the set. It's a data structure designed from the ground up with pretty much one primary mission: to hunt down and eliminate duplicates. So a set really only has two roles, but they're super important. First, no duplicates allowed. You just can't have the same thing in there twice. And second, it's completely unordered. The best way to think of it is like a bag of marbles. You know which marbles are in the bag, but there's no such thing as the first or last one. They're just in there. Okay, let's actually see this in action. Take a look at the syntax here. We're creating a set called data with curly braces, and you'll notice we've deliberately put the number 2 in there twice. Now, based on the rules we just talked about, what do you think is going to happen to that extra 2? And boom, just like that, Python automatically enforces that uniqueness rule. When we print the set, that duplicate 2 is just gone. The output is 1, 2, 3. It's like having an automatic data cleaning machine built right in. Pretty cool, huh? Okay, so a good question pops up here. If we can put things into a set, can we pull them out using their position? I mean, with lists, you could just grab the first item with an index, like numbers 0. So you might wonder if you can do the same thing with a set. And the answer is a hard no. Remember that bag of marbles? Since there's no order, there is no first or second item to grab. If you try to access an element by its index, Python's going to stop you with a type error. And that's not a bug, by the way. It's actually a core part of what makes sets so fast. But this is where their real power comes in. You can do these incredibly fast mathematical-style operations. You can add new elements with .add, you can merge two sets together with .union, or you can find out exactly what they have in common with .intersection. Okay, so sets are perfect for when you just care what's in your collection. But what happens when the label for each piece of data is just as important as the data itself? Well, that brings us to our second powerhouse tool, the dictionary. This is Python's go-to solution for structured labeled data. Honestly, the best way to get it is to think of a real-world dictionary. You look up a word, that's your key, to find its definition, that's the value. In Python, a dictionary is exactly that. It lets you store information by pairing a unique key with its value. Check this out, it's a perfect example. We're making a student dictionary. Notice the pattern. Each item is a pair. The string on the left of the colon, like name, is the key, and the data on the right, like Amit, is the value. This creates this really clear, super readable link between a label and its data. In getting that data back out, it's just so intuitive. Instead of a number index like 0, you just use the key itself inside the square brackets. So you see here, asking for student name instantly gives you back the value Amit. There's no guesswork. Your code says exactly what it's looking for. And you know what's great? Dictionaries are completely flexible. To update a value that's already there, you just reassign it using its key, like we're doing with the age, setting it to 21. And to add a totally new piece of info, you just assign a value to a new key, like adding a city. It really is that simple. And taking stuff out is just as easy. There's a method called .pop that takes a key and it just removes that entire key value pair from the dictionary. So here, running student.pop marks would permanently delete the marks from that profile. All right, time for a little showdown. We've seen what they can each do on their own, but putting them side by side like this is going to make it crystal clear when you should reach for one over the other. This table really just boils it all down, doesn't it? The biggest difference is what they store. Sets are for unique, individual values. Dictionaries are for key value pairs, and that right there tells you when to use them. Reach for a set anytime you need to guarantee uniqueness, and use a dictionary anytime you need to connect a label to a piece of data. Okay, theory is great and all, but let's talk about where you'll actually use this stuff. We'll also look at a few common little traps that can trip you up when you're just starting out. Here's a classic. I mean, you've seen this a million times, right? Tracking unique visitors to a website. Your logs might show Ahmet visiting 10 times, but if you just add each visitor's name to a set, all those duplicates are automatically ignored, and you're left with a perfect, clean list of every unique person who's stopped by. And for something like a user profile, dictionaries are, they're the absolute perfect tool for the job. Every piece of information, the username, the email, their active status, it all has a clear, unambiguous label. It just makes the data so much easier to work with. Now, as you start playing with these, just keep a few common mistakes in mind. First, don't ever try to access a set element by its index. It's unordered, it won't work. Second, remember that dictionary keys have to be unique. You can't have two name keys in the same dictionary. And finally, hey, if your goal is to get rid of duplicates from a list, converting it to a set is almost always the easiest and most efficient way to get it done. Phew, okay, we've covered a ton of ground here with two incredibly useful data structures. Let's do a super quick recap of the most important stuff before we wrap up. So, what's the big takeaway here? It's that you now have two very specialized tools in your Python toolkit. You're going to reach for a set when your main goal is uniqueness, and you need to check for things really fast. And you'll use a dictionary whenever you've got data that needs clear, descriptive labels. So think about it. We now have 4 really powerful ways to store and organize our data in Python. But, just storing data is only half the battle. Which leads to a much bigger question. Once you have all of this information organized so neatly, how do you make it do things? How do you make it act? Well, we're going to start exploring that next time.